I guess the quest is, can a steel butterfly in Oregon, flapping its wings, create a revolution in 3D printing technology for large forms? Yeah, what's the goal of this project? The goal of this project is to take a concept that I had, which is a means of fastening wire to itself rapidly and consistently with a minimum amount of machinery involved to do that, and bring that technology into creation of an industry which would enable fabrication of all kinds of both regular geometries and amorphous shapes. Looking at the current state of the art of 3D printing, the challenges in large-scale creations is that there is a set time involved with almost all the fabricating techniques. This is for 3D plastic printers, the time it takes the material to solidify. The same thing with large-scale concrete structures, such as buildings that are being 3D printed now. In the realm of metal, things are even more challenging because primarily the only metal technology that I know of is the welded bridges that are being made in Europe and similar forms, which are all laboriously welded together with wire welders and attached to robotic heads. So as such, current technologies don't allow for very large scale creation of structures such as building walls or roofs or ceilings, which in this case is what I'm going to attempt to do with this novel technology. What this technology enables is the use of a geometric strategy to connect two pieces of flexible steel to each other quickly through a material deformation process, followed possibly by spot welding, neither of which take very much time at all. So these things can be spun out extremely rapidly to create a whole panoply of shapes depending on one simple change, which is the dimension between the hooks. This is the reason I liken this to a structural DNA, in the sense that it is pairs of strands woven adjacent to each other. Here, I'll bring up this example. Let's see how the camera can see it, where the little hooks enable the creation of a truss form between the larger regular forms, and each one of the hooks is identical, formed by the same forming tool, and thus you have the ability to create truss forms, which of course is the sine qua non of structural engineering, very quickly using a very common material. In this case, you can see I've used a welding wire here to deform these with my crude prototype to investigate whether the wire would form, the hooks would hold, and then everything would fit onto the linear shafts between the webs. Like any concept, I had envisioned that this would work very well, but I needed to make a prototype to observe all the different facets of it as they would exist in any scale. So what I made was a device that would bend the wire and form each hook, and that device consisted of this hinge plate, just like a butterfly, and then I would put this pin in the chuck. Here's the hinge and pin installed in a vise, and here you can see the wire captured by the two halves, and the pin then drives, as it folds, the pin then drives the curve up and forms the completed hook. That would result in each of those little hooks that I have to form, and then I'd have to measure out the distance between. Now the idea is to take this into a more of a roller, which would roll out each hook and potentially snap it right onto the correlating rod that it would be adjacent to. Understanding the effects of scaling. What is really important to understand about this technology and this prototype is that even though I made it out of a very small, thin wire, which obviously is much easier to work with, the idea would be that this could be scaled up to wire dimensions as large as, say, 1/2 an inch in diameter. I'm not sure what the structural limitations of bending the wire would be, but these could then be used to create buildings of a pretty significant scale, since once again what it is creating is trusses. And one of the other features that I didn't delineate before is that there's two possible methods for this fabrication to occur, and one of them is to simply print out all the webs and all of the corresponding rails and deliver them as a kit, which could be snapped together for various types of structures. Secondarily would be to actually have a 3D printer head that would be movable in 3D space, which could then create these structures on the fly, as it were, domes and arches or roofs and such for buildings. Moving forward in time, as I mentioned before, would be the next phase of the development, which would be to create a system of fabricating the hooks much more quickly than my hand-formed butterfly device would do. Thus, this would be the next phase would be to show that the hooks could be formed in a time frame which made all of this economically viable. So I'd love to share this with people in academia or industry who are interested in large-scale 3D printing and a means to move that forward.